Okay, hey guys, it's Sky Godwin with BDX Labs, and today I am back to show you a video that many of my subscribers have been requesting. It is the workup for how to remove the acid or catalyst pTSA from your reaction material. So this will work on the neat reaction if you just added pTSA to CBD. No solvent. The only difference is you would need to add a non-polar organic solvent to that material, dissolve it in that first before doing this procedure. So from there we'll get started. Okay, so our reaction has ceased and we have allowed it to cool off to room temperature. So right now I'm just going to take it apart and gather my material. So this is our material after it's cooled off. As you can see, much of the pTSA acid has precipitated out of solution and crystallized on the walls and in the bottom. First thing we are going to do is we are going to take some distilled water, any kind of generally clean water will work, and we are going to pour about, let's say, 400 to 500 milliliters. That's a little more, but we're going to pour it into a beaker, and then we want to know what the pH of this is before we start. So I have some pH paper here. And it looks like the pH of our water is sitting right at 6. I'm just going to add that water, and as you can see, it separates into aqueous and organic, and the purpose of that is basically just a quench. It's going to dissolve the majority of your acid and pull it from the organic layer. So after that, we're just going to transfer it into a separatory funnel. Tip from a professional here: before you pour it into your separatory funnel, make sure the valve is closed. There have been many times I have done that and poured it into an open funnel, which is no fun. Another thing, it's nice to have a beaker underneath before you pour, just in case. And I forgot the stir bar, so I dumped my stir bar in there. Oh well. Now we're just going to give it a good shake. And we're going to allow these layers to separate, which happen pretty quickly. At this point, we can drain our water layer off. To verify we pulled some acid out of the solution, we're going to check the pH again. So we went from pH 6 to, looks like 2, pH 2, so it's a good considerable amount of change. For the next wash, we are going to use sodium hydroxide for our base. You can use sodium bicarbonate, potassium hydroxide. There's a variety of bases that work equally well. I prefer sodium hydroxide because it doesn't tend to stick around in the material, so to speak. I just added 2 grams, and I'm just going to check my pH periodically to see where I want it. So pH 13, way too high. Still pH 13, so still too high. I'm used to doing this on a large scale, so I don't often make small batches. looking a little better. So with these pH papers that go 0 to 13, it's very hard to read between like 10, 11, 12, 13 pH because the colors are so similar. So when working in that range, I like to use papers that are a little more selective, that read between 10, 10.5, 11, 11.5, and 12, because I like my washes to be between 10 and 11.5 pH. So we're at 12. I still need to lower it. I hope that does a good job. Perfect. We're at 11.5. Perfect. So I'm going to pour about 500 milliliters of this pH 11.5 water into this set funnel. And give it a good shake. See, it's starting to turn pink. I'm gonna let this separate. Now that this has separated, you might notice the cloudiness in the aqueous layer. That is because the strong base has actually pulled some residual like lipids, fats and waxes out and essentially turned them into a type of soap, a crude form of soap, if you will. So we are going to go ahead and drain that off and separate that out. I don't know how well you can see the surface of that, but you can kind of see some of the waxes that have come out. They're kind of like sticky. And just for kicks, we'll go ahead and test the pH of this. Look at that. We started at 11.5. and it's gone down to 10. Maybe even lower. Yeah, look at that. Took it down to 7. From 11.5 to 7. So that just goes to show, even after that initial water wash, there was still a ton of acid left in that solution. Now, typically I would do 3 sets of the base wash. For illustration purposes today, I'm only going to be doing the 1, but typically I would do 3 sets to make completely certain there is no acid left in that solution. Now, typically I would do 3 sets of the base wash. For illustration purposes today, I'm only going to be doing the one, but typically I would do 3 sets to make completely certain there is no acid left in that solution. At this point, we will do a brine wash. So we are just going to take basically a random amount of salt and add some water to it. We want to make a saturated brine solution. So we want to make sure that the water is holding as much dissolved salt as possible. Yeah, so I believe that is definitely a saturated solution. As you can see, there is still a fair bit of salt on the bottom that has not dissolved. Now, I don't want to pour that salt in there. I just want to get the solution in there. And what this does is it helps to dehydrate the solution. There is going to be small amounts of water in this solution that we can't really see. The brine solution helps to grab a hold of that and dry out our solution further. And the brine solution typically separates really fast. You'll see a color change again. That is basically from water being pulled out. Before, it appeared cloudy and opaque and lighter because of lots of little water droplets floating around. It made it appear lighter essentially. So it looks like we have pulled a good amount of water out. So, last thing we are going to do today is make sure that it is completely dried out by pouring it over sodium sulfate, anhydrous sodium sulfate. So, I am just going to take a random amount. That's probably way too much, but it's okay, we buy it by the ton. Just going to take some sodium sulfate, and I am just going to drain my now delta 8 hexane solution onto the sodium sulfate and let it swirl around. I'm going to also rinse my set funnel with additional hexane to make sure I get all the residue out. At this point, I need to separate that from the sodium sulfate, so I am going to pour my solution through a filter paper into a clean flask. Okay guys, there you have it. We are finished with the workup, which this is what we're left with, which is about 600 milliliters of hexane. That contains our 100 grams of now delta 8 delta 9 THC in hexane solution. So at this point, you need to remove the hexane. That is best accomplished through rotary evaporator, and from there you would want to distill this. I do not condone anyone trying to recreate these procedures at home or without professional knowledge, equipment, and legalities. Also, I would never encourage or want anyone to consume anything or ingest into their body anything that has not been tested at an accredited professional laboratory. This is now free from all pTSA acid, and it is just our delta 8, delta 9 THC in hexane. It now needs to be distilled, and that will be it. Please do not attempt to recreate anything you see here. Do not attempt to recreate any of this at home or without professional knowledge, licensing, and equipment. I do not condone anybody attempting to consume anything that is made and not tested in a professional laboratory for all heavy metals, residual acids, toxins, etc. If you like this, guys, please like, share, subscribe, and click the bell for notifications. I will be posting more content bi-weekly. Thanks, guys. See ya.